What if I told you that the most complex, most powerful, and most mysterious object in the known universe is not light years away in some distant galaxy, but is sitting right between your ears? And what if I told you that for all its power, it's a master of deception, constantly editing your reality without your permission? That 3-pound universe of tissue and electricity is your brain, the very source of what we call intelligence. And over the next journey together, we are going to unpack exactly 100 of the most incredible facts about that spark that defines us, rearranges our world, and pushes us to the stars. Let's not waste a second. Our exploration has to start with the sheer, mind-boggling scale of the hardware itself. The first fact is that your brain isn't just complex, it is a structure of almost unimaginable density. It houses somewhere around 86 billion neurons. For a long time, the number was quoted as 100 billion, but a precise 2009 study gave us this more accurate, yet no less staggering figure. Now, 86 billion is a number so large it's hard to grasp. Imagine the Milky Way galaxy, our home, with its estimated 200 to 400 billion stars. You are carrying a structure in your head with nearly half as many core processing units as there are stars in our entire galaxy. But the real magic isn't in the neurons themselves, it's in their connections. Each of those neurons can form thousands of links, called synapses, with other neurons. The total number of synapses in the average adult brain is estimated to be somewhere between 100 to 500 trillion. That network, that web of connections, is where all thought, memory, and consciousness lives. It is more intricate and has more possible pathways than all the communication networks on planet Earth combined. But running a universe in your head comes at a steep price. And that brings us to the astonishing biological cost of our intelligence. While your brain makes up only about 2% of your total body weight, it consumes a shocking 20% of your body's total oxygen and calories. It is, by far, the most metabolically expensive organ you own. For a newborn baby, that number is even more extreme, with the brain demanding upwards of 60% of their energy intake. This incredible energy drain is the result of those neurons firing trillions of signals, a constant electrical storm that powers your every thought. From an evolutionary standpoint, this was a massive gamble. In times of famine or scarcity, dedicating so much precious energy to an organ that doesn't hunt, digest, or fight was a risky strategy. The fact that evolution doubled down on this energy-hungry machine tells you just how massive the payoff for intelligence must have been for our survival as a species. It's a biological testament to the sheer power of thought. So we have this powerful, energy-hungry machine, but what exactly is the intelligence it's producing? We often talk about it as a single thing, like a score you can get on a test. But one of the most fundamental discoveries about intelligence is that it isn't monolithic at all. It's better understood as having at least two major components: fluid intelligence and crystallized intelligence. Think of fluid intelligence as your raw processing power. It's your ability to solve new, unfamiliar problems, to see patterns, and to use logic in novel situations without relying on pre-existing knowledge. It's what you use to solve a puzzle you've never seen before. Crystallized intelligence, on the other hand, is the library of facts, skills, and knowledge you've accumulated throughout your life. It's your vocabulary, your historical knowledge, your ability to do long division. Here's the fascinating part: they age differently. Your fluid intelligence, that quick, adaptable reasoning, generally peaks in your early 20s and then begins a slow, gradual decline. But your crystallized intelligence, your library of knowledge, can continue to grow and strengthen well into your 60s, 70s, and beyond. This is why a grandmaster chess player might lose some raw calculation speed, but can defeat younger players through a vast, accumulated knowledge of strategies. This dynamic nature of intelligence becomes even more mysterious when we look at populations over time, leading us to one of the most puzzling phenomena in psychology, the Flynn effect. Named after political scientist James Flynn, who did extensive research on it, the Flynn effect is the discovery that raw scores on IQ tests have been steadily and significantly increasing all over the world for the past century. On average, each generation has scored higher than the one before it. This isn't a small jump. We're talking about an increase of roughly 3 IQ points per decade. This means that if you took an IQ test from 1920, you would likely score as a genius by their standards. And conversely, the average person from 1920 would score around 70 on a modern test, the technical threshold for intellectual disability. This is obviously not the case, so what's going on? It's not that we're evolving into a super species in just a few generations. The leading theories suggest the cause is environmental. Better nutrition, more formal education, and, most importantly, an increasing exposure to complex, abstract problem-solving in our daily lives, from video games to complex user interfaces. The Flynn effect proves that intelligence isn't just a fixed genetic trait, it's profoundly shaped by the world we live in. Speaking of being shaped by the world, let's talk about one of the most celebrated outputs of the human mind, creativity. For a long time, researchers debated whether intelligence and creativity were the same thing. Are smart people automatically creative? The answer, it turns out, is a fascinating yes, but only up to a point. This is known as the threshold theory of creativity and intelligence. The theory suggests that a certain baseline level of intelligence is necessary for significant creative work. It's hard to write a brilliant novel if you have a very limited vocabulary, or to make a breakthrough in physics without understanding the math. Most studies place this IQ threshold at around 120. Below that number, there's a strong correlation. The higher the IQ, the higher the potential for creativity. But here's the twist. Above an IQ of 120, that correlation almost completely vanishes. A person with an IQ of 160 is no more likely to be a creative genius than someone with an IQ of 125. Beyond that threshold, other factors, like personality traits, openness to experience, a tolerance for ambiguity, a willingness to take risks, become far more important predictors of real-world creativity. This incredible capacity for problem-solving and creation makes it easy to think we're unique. But are we the only spark of high intelligence on this planet? For our final fact in this chapter, we turn to the skies, not to the stars, but to the birds. Specifically, corvids, the family that includes crows, ravens, and jays. These birds demonstrate a level of intelligence that continually shatters our expectations for a non-primate brain. Crows can not only use tools, but can actually make them, bending wires into hooks to fish out food. They understand complex physics concepts like water displacement, dropping stones into a tube to raise the water level to get a floating treat, a feat that stumps many young children. They can recognize and remember individual human faces for years and even pass that information on to other crows, teaching their friends and family which humans are friendly and which are a threat. What's most incredible is that their brains are structured completely differently from ours. Their intelligence is a stunning example of convergent evolution, where two completely different evolutionary paths arrive at the same sophisticated solution. A thinking, problem-solving mind. They remind us that the spark of intelligence is not a uniquely human phenomenon, but a puzzle that nature has solved more than once. If you held the brain of a sperm whale in your hands, and you'd need a forklift to do it, you'd be holding the largest brain in the history of our planet. It weighs about 18 pounds, over 5 times heavier than your own. So, does that make the sperm whale 5 times smarter? Not even close. This is where the story of intelligence gets truly fascinating, moving beyond the simple idea of bigger is better. Because for our 7th amazing fact, while the sperm whale does indeed possess the largest known brain, its intelligence is dwarfed by the sheer complexity and organization of ours. Their massive brain is largely dedicated to processing sonar information from the vast, dark depths of the ocean and controlling an enormous body. It's a biological supercomputer built for a very specific and very different purpose. This immediately tells us that raw size isn't the whole story. It's like comparing a giant, simple calculator to a sleek, modern smartphone. One is bigger, but the other has an infinitely more complex and versatile operating system. This is the first major clue that the secret to intelligence lies not in the scale of the hardware, but in the elegance of its design. So if size is a poor metric, how do scientists create a better comparison? That brings us to fact number 8. They use a clever calculation called the encephalization quotient, or EQ. This isn't just about brain weight. It's the ratio of an animal's actual brain mass to the predicted brain mass for an animal of its size. Think of it as a brain-to-body bonus score. A score of 1 means the brain is exactly the size you'd expect. Humans, however, blow this curve completely. Our EQ score is a staggering 7.5. This means our brain is over 7 times larger than what you'd expect for a primate of our body weight. Dolphins, our clever aquatic cousins, come in second with an EQ around 4.2. The sperm whale? Despite its massive brain, its EQ is quite low because its body is just so incredibly colossal. The EQ reveals that what makes us special isn't just a big brain, but a brain that is disproportionately, almost absurdly large for the body it has to run. It's pure, concentrated processing power. But even this doesn't get to the heart of the matter. To do that, we have to zoom in, way in. Forget size, let's talk numbers. And fact number 9 is one of the most famous in neuroscience. The average human brain contains approximately 86 billion neurons. For decades, the number was rounded up to a neat 100 billion. But a groundbreaking 2009 study by neuroscientist Susanna Herculano-Husel gave us this more precise and, frankly, more beautiful figure. 86 billion. What does that even mean? It means you have more neurons in your skull than there are stars in many galaxies. If you tried to count them 1 per second, it would take you over 2,700 years. These aren't just passive cells. They are the individual singers in the grand chorus of your consciousness, each one a tiny biological switch, firing, connecting, and weaving the tapestry of your thoughts. Now, hold on. If the secret is the number of neurons, then we've just solved it, right? The species with the most neurons wins. Well, nature loves a good plot twist. Which leads us to fact number 10, a real mind-bender. The African elephant's brain contains roughly 257 billion neurons, 3 times more than a human brain. So why aren't we living on a planet ruled by philosophical elephants pondering the meaning of existence? The secret is in the location. A staggering 98% of the elephant's neurons are packed into its cerebellum, the area at the back of the brain responsible for motor control. This makes perfect sense when you have to coordinate a massive body and a prehensile trunk with more than 40,000 individual muscles. It's an incredible feat of motor engineering, but it's not the seed of abstract thought. Humans, on the other hand, play a completely different game, and that game is all about the cerebral cortex. This brings us to fact number 11. Humans have the highest number of neurons in their cerebral cortex of any species on Earth. We have about 16 billion neurons packed into that wrinkly outer layer of our brain, the part responsible for language, reasoning, and complex problem solving. The elephant? Only about 5.6 billion. It's a stunning difference. This tells us that the ultimate currency of higher intelligence isn't just the total number of neurons, but the number of neurons dedicated to the thinking part of the brain. Our brain prioritizes cognitive power above all else, dedicating a massive chunk of its cellular real estate to the cortex. It's like having a computer where almost all the processing chips are concentrated in a single hyper-advanced motherboard. But even 16 billion cortical neurons would be useless if they weren't connected. And the scale of this connectivity is where the numbers become truly astronomical. For fact number 12, each of those billions of neurons can form thousands of connections with other neurons. These connections are called synapses. The total estimated number of synapses in the human brain is, well, it's almost incomprehensible. The most common estimates place it somewhere between 100 trillion and 1 quadrillion. A quadrillion is 1,000 trillion. Let me try to put that in perspective. The Milky Way galaxy has about 200 to 400 billion stars. This means you have, at a minimum, 250 times more synapses in your head than there are stars in our entire galaxy. It is these connections, this vast, intricate, and ever-changing web, that allow for the complexity of memory, learning, and consciousness. It's not a collection of individual units, it's a hyper-connected network of staggering density. This network isn't just dense, it's also lightning fast. And that's our 13th fact. Information can travel through your neurons at speeds of up to 268 miles per hour. That's faster than a Formula One race car at full throttle. This incredible speed is made possible by a fatty substance called the myelin sheath, which wraps around the axon, or the wire, of the neuron. It acts like the plastic insulation on an electrical cable, preventing the signal from leaking out and allowing it to jump between gaps in the sheath in a process called saltatory conduction. This biological superhighway allows your brain to send a command to your muscles, process a visual scene, or recall a memory in literal milliseconds. It's this combination of massive parallelism, a quadrillion connections, and blistering speed that forms the true engine of our intelligence. It's a secret dance of chemistry and electricity, a biological ballet of unimaginable complexity happening inside your head, right now. So, we've explored what intelligence is, but now we arrive at the million-dollar question, the one that's launched 1,000 debates. Where does it come from? Is it etched into our DNA from the moment of conception, a fixed blueprint passed down through generations? Or is it a blank canvas, painted and shaped by our experiences, our education, our world? This is the epic battle of nature versus nurture, and the truth, as we're about to see, is far more tangled and fascinating than a simple 50-50 split. And that brings us to a foundational and often misunderstood fact about intelligence. When scientists try to unravel this genetic knot, they use a term called heritability. And for IQ, the heritability estimate is surprisingly high, typically landing somewhere between 50% and 80%. Now hold on, because that number does not mean that 80% of your specific intelligence came from your parents. That's a common mistake. What it means is that for a given population, 50 to 80% of the differences in IQ scores we see between people can be explained by their genetic differences. It's a measure of variation. But here's the truly bizarre part. This genetic influence gets stronger as we age. For toddlers, heritability is only about 20%, meaning environment is king. But by the time we're adults, it can climb as high as 80%. It's as if our genes lay out a path, and the older we get, the more we tend to follow that specific path, actively seeking out environments that suit our genetic predispositions. But if our genes have such a powerful say, especially as we get older, then how on earth do you explain one of the most baffling phenomena in the history of psychology? It's called the Flynn effect, and it's our next mind-bending fact. Starting in the early 20th century, researchers noticed something astonishing. Raw scores on IQ tests were steadily and substantially increasing all over the world, generation after generation. We're talking an average rise of about 3 IQ points per decade. This means the average person today would score as a near genius if they took an IQ test from 1920. Our genes simply do not change that fast. Evolution doesn't work on a decade-long timescale. This massive global boost in cognitive ability has to be environmental. Researchers point to a cocktail of factors: vastly improved nutrition, more years of formal schooling, and, perhaps most importantly, a world that increasingly demands abstract thinking. We're constantly interacting with complex systems, from smartphone interfaces to intricate storylines in our entertainment, essentially training our brains in the exact kind of problem-solving that IQ tests measure. The Flynn effect is a powerful testament to the power of nurture to elevate an entire population. So we have a paradox. The genetic influence gets stronger with age, yet the environment has been lifting all of us up for a century. How can both be true? To untangle this, scientists rely on nature's own perfect experiment: identical twins. Specifically, identical twins who were separated at birth and raised in completely different homes. Their DNA is, for all intents and purposes, a 100% match. The only major difference is their environment. The landmark Minnesota study of twins reared apart found that these twins, who were often total strangers until adulthood, had IQ scores that were shockingly similar. Their IQs correlated at about 0.76, which is incredibly high. For comparison, fraternal twins, who share about 50% of their genes and are raised in the same house, only have an IQ correlation of around 0.55. Even more telling, identical twins raised together have a correlation of about 0.86, which is not that much higher than those raised apart. This provides some of the most powerful evidence that our genes don't just suggest an outcome, they write a very, very strong first draft of our cognitive abilities. But the story gets even stranger when you look at it from the opposite angle, which leads to our next fact. Let's look at adoption studies. Here, you have children with no genetic relationship to their parents, raised in the same environment. In early childhood, their IQs show a modest correlation with their adoptive parents, proving that a stimulating and nurturing home does indeed provide a cognitive boost. But here is the jaw-dropping twist. As these adopted children grow up and move into late adolescence and adulthood, that correlation with their adoptive parents' IQ fades away to almost zero. And at the same time, their correlation with the IQs of the biological parents they may have never even met gets stronger. This phenomenon, known as the Wilson effect, suggests that as we mature, we gain more autonomy to shape our own lives. And how do we shape them? We instinctively gravitate towards activities and challenges that align with our innate, genetically influenced abilities and interests, a process called niche picking. So the brainy kid seeks out the library, and the artistically inclined kid seeks out the studio, each reinforcing their genetic predispositions over time. This powerful genetic thread begs the question: is there a genius gene? A single switch that flips someone from average to extraordinary? The answer, our next fact reveals, is a definitive no. Intelligence isn't a monologue, it's a symphony. It is one of the most highly polygenic traits in the human genome, meaning it's influenced by thousands upon thousands of genes, each contributing just a tiny, almost imperceptible effect. Modern genome-wide association studies, or GWAS, have identified over 1,000 specific gene variants associated with educational attainment and cognitive performance. Think of it less like a single blueprint and more like a massive construction crew where every worker has a slightly different job. There's no foreman gene barking orders. Instead, it's the combined, coordinated effort of all these tiny genetic workers that builds the complex structure of our intellect. This complexity is why we can't simply engineer intelligence, and why two highly intelligent parents can still have a child with average intelligence, or vice versa. The genetic lottery is incredibly complex, and that brings us full circle. If genes are the construction crew, then nurture is the quality of the materials and the safety of the construction site. And our final fact in this chapter shows just how catastrophic a poor environment can be. Tragic but illuminating studies of children raised in severely deprived Romanian orphanages in the 1980s and 90s showed devastating effects on cognitive development. These children had food and shelter, but lacked cognitive stimulation, social interaction, and emotional support. Their average IQs were languishing in the 60s, a level considered intellectually disabled. But then, a remarkable intervention happened. When these children were adopted into nurturing, enriched, and loving foster homes, they showed incredible gains in IQ. The children adopted before the age of 2 saw the most dramatic recovery, gaining dozens of points and often catching up to their peers. This demonstrates a crucial concept. Genes may define a person's potential range of intelligence, but it is the environment, the nutrition, the love, the stimulation, the education that determines where within that range a person will ultimately land. The most brilliant blueprint in the world can't become a skyscraper without steel, concrete, and a chance to be built. What if I told you the single most famous test in history, a number that has defined geniuses and shaped lives for over a century, was created for the exact opposite reason we use it today? It wasn't designed to find the next Einstein. It was designed to find the children who were falling behind, to help them, not to label them. We're about to crack open the strange, surprising, and often misunderstood story of the intelligence quotient, or IQ. This is the code behind the number. So let's turn back the clock to early 20th century Paris. The French government had just made a revolutionary decision: mandatory public education for all children. It was a noble idea, but it created a brand new problem. For the first time, classrooms were filled with students from every conceivable background, and it quickly became obvious that some children were struggling far more than others. The government needed a way to identify these students, not to kick them out, but to give them specialized assistance. And that's where psychologist Alfred Binet stepped in. This leads us to our next jaw-dropping fact. The world's first practical intelligence test, the Binet-Simon scale, was never intended to measure a fixed, inborn quantity of intelligence. Binet's goal was purely diagnostic. He developed a series of tasks, things like following commands, copying patterns, naming objects, and putting things in order, that he believed were representative of a typical child's abilities at various ages. If a 7-year-old could only complete the tasks that most 5-year-olds could, Binet identified them as needing support. It was a tool for compassion, a way to direct educational resources where they were most needed. And here's where the story takes a sharp turn, a turn that would have horrified its own creator. Alfred Binet was fiercely against the idea that his test could distill the complexity of a human mind into a single, permanent number. He believed intelligence was malleable, not fixed. He famously said, "It must be added that the use of these measures should not serve to sanction a pessimistic and sterile belief in the immutability of intelligence." He saw his scale as a starting point for improvement, not a final verdict. The popular, modern idea of IQ as a lifelong label of cognitive rank is a complete perversion of his original vision. He didn't want to crown geniuses, he wanted to lift up the students who were struggling. The irony is staggering. The test designed to foster educational inclusion became a tool used, at times, for intellectual segregation. So if Binet didn't invent the concept of the IQ score, who did? The credit, or perhaps the blame, for that goes to a German psychologist named William Stern in 1912. He was the one who looked at the data from tests like Binet's and proposed a seemingly simple way to express the results as a single number. He called it the intelligence quotient, which is where we get IQ. This is the fact. The classic IQ formula that so many of us learned about was mental age divided by chronological age multiplied by 100. So, if a 10-year-old child could pass the same tests as the average 12-year-old, their mental age was 12. You take 12, divide it by 10, get 1.2, and multiply by 100 to get an IQ of 120. Conversely, if that same 10-year-old performed at an 8-year-old level, their IQ would be 80. This formula, popularized in America by psychologist Lewis Terman with his Stanford Binet test, was elegant, easy to understand, and it completely changed the game. It transformed Binet's diagnostic tool into a competitive ranking system. But hold on, because if you've ever taken a modern, official IQ test, that formula wasn't used at all. In fact, that century-old equation has a massive, glaring flaw. Think about it. What does it even mean for a 40-year-old to have a mental age of 50 or 60? The concept completely breaks down in adulthood. The mental age to chronological age ratio only really works for children whose cognitive abilities are developing rapidly and predictably. For adults, it's meaningless. That's why modern IQ tests, like the Wechsler Adult Intelligence Scale, use a totally different method called a deviation IQ. Instead of comparing you to a child's developmental stage, the test compares your score to the scores of a massive, representative sample of people in your own age group. The results are then plotted on a normal distribution curve, a bell curve. The average score is arbitrarily set to 100. Your score simply indicates how far you deviated from that average. A 115 means you scored one standard deviation above the average for your age, while an 85 means you scored one below. It's a statistical ranking, not a measure of your mental age. Now, this is where things get truly bizarre. The entire system of scoring relies on that bell curve with an average of 100. But what if the average keeps changing? Well, it does. In one of the most mysterious and profound findings in the history of psychology, we've discovered that raw scores on IQ tests have been steadily and significantly rising for over a century. This phenomenon is called the Flynn effect, named after the late political philosopher James Flynn, who documented it extensively. On average, humanity has been gaining about 3 IQ points per decade. This means a person who scored the average of 100 back in 1950 would likely score around 75 or 80 on a modern test, while a person scoring 100 today would have been considered near genius level with a score of about 125 by 1950 standards. This presents a massive problem for test takers. If they didn't do anything, the average IQ would creep up to 110, then 120, then 130, making the entire 100-point average system meaningless. So, and this is our next fact, IQ tests have to be periodically renormed. Essentially, every 15 to 20 years, the tests are made harder. The questions are updated, the scoring is adjusted, and the baseline is reset to ensure that the average score for the current population remains 100. You are literally being graded on a tougher curve than your parents or grandparents were. The Flynn effect is a global phenomenon, observed in dozens of countries, and nobody is entirely sure what causes it. Better nutrition, more complex and stimulating environments, more abstract thinking in daily life, and better education have all been proposed as factors. We aren't necessarily becoming more innately intelligent, but we are becoming much, much better at the kind of abstract problem solving that these tests measure. Which brings us to the ultimate question, the core of the enigma. What does that number, that IQ score, actually mean? What is it truly measuring? While a high IQ score is one of the strongest known predictors of positive life outcomes like academic achievement and professional success, it is not a measure of your total mental worth. IQ tests are specifically designed to measure certain types of cognitive abilities, things like logical reasoning, abstract thinking, spatial visualization, pattern recognition, and working memory. But that leaves a universe of human intelligence completely off the table. They don't measure creativity, emotional intelligence, practical wisdom, social skills, or moral character. An IQ score is a snapshot of a specific set of mental tools, not the entire workshop. It can tell you how well someone might solve a puzzle, but not how well they'll lead a team, write a symphony, or raise a family. The map, as they say, is not the territory. And understanding that distinction is the first step to truly understanding the vast, uncharted landscape of the human mind. Imagine you're walking through a park and you see a crow drop a nut onto the road. You smile, thinking it's a bit clumsy. But then it waits. It watches the traffic light, and only when the walk signal flashes and the cars stop does it fly down to retrieve its perfectly cracked snack. At that moment, you have to ask yourself, did that bird just use traffic laws better than the guy who cut you off this morning? We tend to think of intelligence as a human monopoly, a private club with a strict no animals allowed policy. But the truth is, the world is filled with brilliant minds hiding in feathers, fur, and even tentacles. Fact 28. So let's start with that clever crow. We're not just talking about using cars as nutcrackers. Crows possess an astonishing grasp of physics that was once thought to be exclusively human. Scientists presented crows with a tube of water containing a floating treat, but the water level was too low for them to reach it. Without hesitation, the crows began dropping pebbles and heavy objects into the tube, raising the water level until the treat was within reach. They instinctively understood the principle of water displacement, literally acting out Aesop's fable of the crow and the pitcher. They even chose the larger, heavier stones over smaller, lighter ones, showing they understood which tools were most effective for the job. From a feathered genius in the sky, we dive deep into the ocean to meet a mind so alien it's like something from science fiction. Fact 29. The octopus has a profoundly decentralized nervous system. In fact, 2/3 of its neurons are located not in its brain, but in its arms. This means each arm can essentially think, taste, and act on its own, solving complex problems independently while the central brain supervises. It's like having 8 smaller, semi-independent brains working in tandem with a central processor. This is why an octopus can be solving a puzzle with one arm, exploring a cave with another, and fending off a predator with a third, all at once. They are legendary escape artists, known to unscrew jar lids from the inside, and can solve intricate mazes for a food reward. Speaking of aquatic intellect, another ocean dweller has a sense of self so strong it gives itself a name. Fact 30. Dolphins communicate using a complex series of clicks and whistles, and early in life, each dolphin develops a unique signature whistle. This whistle is their personal identifier, their name, which they use to call out to each other and announce their presence. Other dolphins can remember and even mimic a specific dolphin's signature whistle to get its attention, just like you would call a friend's name across a crowded room. This implies not just complex communication, but an awareness of self and others as distinct individuals, a cognitive leap that is incredibly rare in the animal kingdom and a cornerstone of higher intelligence. Now, let's leave the water and head to the farm, where you'll find an animal that's often unfairly stereotyped. Fact 31. Pigs are not only clean and emotional, they are shockingly clever, capable of a level of abstract thought that rivals that of a human toddler. In one astounding study, pigs were shown a reflection of a hidden bowl of food in a mirror. They didn't attack the mirror or get confused. Instead, they quickly processed the information, understood the concept of reflection, turned around, and went directly to the actual hidden food. This ability to connect a 2D reflection with a 3D reality demonstrates a high degree of self-awareness and problem-solving that many other animals, and even young human children, struggle to master. They can even learn to play simple joystick-controlled video games. From a single brilliant mind to the power of a collective consciousness, let's get a bit smaller. Fact 32. Ants might seem like simple automatons, but their colonies operate with a staggering level of swarm intelligence, and some have even mastered mathematics for survival.
The Saharan desert ant, for instance, forages in a barren landscape with almost no visual cues. To find its way back to the nest, it doesn't use sight or scent. Instead, it literally counts its steps. Scientists tested this by either shortening or lengthening the ant's legs after they'd reached a food source. The ants with shorter legs undershot the nest on their return, while those with stilts overshot it, proving they were relying on an internal pedometer, a precise built-in calculator for navigation. It's one thing to count your steps, but what about remembering a human face, especially a face you don't like? Fact 33. Magpies, another member of the hyper-intelligent corvid family, have an uncanny ability to recognize and remember individual human faces for years. Researchers at a university campus conducted an experiment where some people would be threatening to magpie nests while others were neutral. The magpies not only learned to identify the dangerous individuals out of a crowd of thousands of students, but they would selectively swoop down and scold only those people. This grudge lasted for years, proving they have incredible long-term memory and sophisticated social recognition skills, essentially creating a mental most wanted list for humans who've wronged them. Remembering a face is one thing, but knowing what's going on behind that face is another level entirely. Fact 34. Chimpanzees, our closest living relatives, have demonstrated a profound theory of mind, the ability to understand that others have their own beliefs, desires, and perspectives. This allows for one of the most sophisticated cognitive feats, deliberate deception. In controlled experiments, a lower-ranking chimp was shown where food was hidden. When a dominant, rival chimp entered the enclosure, the knowledgeable chimp would often actively mislead its rival, leading it to a different, empty location. Only after the dominant chimp had given up and left would the clever one sneak back to the real location and claim its prize. This isn't just instinct. It's a calculated act of strategic thinking based on predicting and manipulating another's mind. It proves that we aren't the only ones on this planet capable of a little bit of cunning. We've seen animals use physics, abstract thought, and even mathematics. And we're only just scratching the surface. What happens when intelligence is no longer bound by biology at all? We've spent a lot of time exploring the raw processing power of the human brain, the kind of intelligence measured in numbers and test scores. But what if I told you the most powerful form of intelligence has almost nothing to do with solving complex equations or memorizing historical dates? What if the true genius lies not in what you know, but in what you feel, and more importantly, what you understand about the feelings of others? We've talked about the brain's logic. Now it's time to explore the heart's. This brings us to our next mind-bending fact. While it feels like a very modern buzzword, the concept of emotional intelligence, or EQ, wasn't just invented in a corporate seminar last Tuesday. Its modern popularity exploded in 1995 with psychologist Daniel Goleman's groundbreaking book, but its intellectual roots run much, much deeper. We have to travel all the way back to the 1920s when a psychologist named E.L. Thorndike first proposed the idea of social intelligence, which he defined as the ability to understand and manage men and women, boys and girls, to act wisely in human relations. For decades, this softer side of intellect was largely overshadowed by the focus on cognitive abilities measured by IQ tests. It took over 70 years for the world to catch up and realize that Thorndike was onto something revolutionary. That our ability to navigate the complex, messy, and beautiful world of human emotion is a distinct and incredibly powerful form of intelligence in its own right. So, what is this hidden superpower actually made of? Well, according to the models that Goleman popularized, emotional intelligence isn't just one thing. It's a suite of skills built upon 4 core pillars. Think of it like building a house. The foundation is self-awareness. The ability to recognize and understand your own moods, emotions, and drives, as well as their effect on others. Do you know why you're feeling anxious or irritable? That's self-awareness. Built on that foundation is self-management or self-regulation. This is the ability to control or redirect those disruptive impulses and moods. It's the pause you take before sending an angry email, the deep breath before reacting to criticism. Once you can manage yourself, you can start building the upper floors. The third pillar is social awareness, which is primarily about empathy. This is the skill of understanding the emotional makeup of other people, the ability to walk into a room and instantly get a read on the atmosphere. Finally, with all that in place, you can build the roof, relationship management. This is the culmination of the other three skills, allowing you to build rapport, find common ground, manage networks, and inspire and influence others. It's not just about being nice. It's about being effective. Now, you might be thinking, that's all well and good, but give me the IQ points. I want to be a genius. But here's a fact that might just change your mind. When researchers track success, not just in careers, but in life overall, high emotional intelligence is a far better predictor of who will thrive than a high IQ. Studies have shown that while a certain level of cognitive intelligence is necessary to get your foot in the door for complex jobs, it's EQ that determines who becomes a star performer and an effective leader. One massive study of thousands of workers found that nearly 90% of top performers were high in emotional intelligence. In fact, people with average IQs outperform those with the highest IQs 70% of the time. Why? Because high EQ individuals build stronger relationships, navigate office politics more effectively, handle pressure with grace, and inspire loyalty and hard work in their teams. It extends beyond the office, too. Higher EQ is linked to more stable marriages, deeper friendships, and greater overall life satisfaction. The smartest person isn't always the one with the answers, but the one who knows how to ask the right questions and truly listen. And here's perhaps the most crucial and hopeful fact about this entire concept. Unlike your IQ, which tends to be relatively fixed after your late teens, your emotional intelligence is not set in stone. It is profoundly malleable. You can actively learn, develop, and increase your EQ at any stage of your life. This is a game changer. It means that with conscious effort, you can fundamentally upgrade your ability to succeed and find happiness. How? Through practices like mindfulness meditation, which strengthens the connection between your emotional centers and your rational brain. Or by keeping a journal to improve self-awareness, asking yourself why you felt a certain way during the day. You can practice active listening, where you focus completely on what someone else is saying without planning your response. You can even deliberately put yourself in other people's shoes, trying to understand their perspective even when you disagree. Every single social interaction is a chance to practice and strengthen your EQ muscles. It's a lifelong skill that pays dividends in every aspect of your existence. But to train those muscles, you first have to understand the beast you're trying to tame. Have you ever completely overreacted to something small? Snapped at a loved one for a minor mistake, or felt a surge of panic over a harmless comment? There's a neurological reason for that, and it's a stunning piece of our mental architecture. Your brain has an emotional first responder called the amygdala. It's part of the ancient limbic system, constantly scanning for threats. When it perceives one, real or imagined, it can trigger the fight or flight response in an instant, flooding your body with stress hormones before the more logical, rational part of your brain, the neocortex, even has a chance to process what's happening. This is called an amygdala hijack. Your emotional brain literally hijacks your rational brain. It's a brilliant survival mechanism if a tiger is chasing you, but it's less helpful when your boss sends you a vaguely worded email. Understanding this hijack is the first step in self-management. Recognizing that initial emotional flash and giving your thinking brain a moment to catch up and ask, wait, is this really a tiger? And that powerful emotional wiring doesn't just operate inside your own skull. It constantly reaches out and connects with others in a way that's almost invisible. This leads to our final fact on this topic. Emotional contagion is a scientifically proven phenomenon. You can literally catch an emotion from someone else, just like you'd catch a cold or a yawn. When you interact with someone, your brain's mirror neurons subtly mimic their facial expressions, body language, and tone of voice. This mimicry then generates the corresponding emotional state inside of you. It's why one person's panic can set off a wave of anxiety in a crowd, or why a friend's genuine laughter can instantly lift your own spirits. This is the biological basis of empathy. People with high social awareness are particularly attuned to this process, allowing them to feel with others, but it affects all of us. The next time you walk into a room and immediately feel the vibe, whether it's tense or joyful, you're not imagining things. You're experiencing the invisible, powerful, and constant broadcast of human emotion. So we've seen how intelligence isn't just about cold, hard logic, but also about the profound wisdom of our emotions. It governs our success, our relationships, and our own inner peace. But what happens when intelligence goes off script entirely? When it doesn't follow the rules of logic or emotion, but instead creates new worlds out of thin air? Next, we're going to step into the vibrant, chaotic, and beautiful realm of creative intelligence. Imagine your brain is a sprawling, living city. With every new experience, a new street is paved. Every skill you learn is a new skyscraper rising towards the clouds. And every memory is a light flickering on in a window. This isn't just a metaphor. Your brain is not a static piece of hardware you're born with. It's a dynamic, ever-changing landscape of connections, and you are its chief architect. For centuries, we believed intelligence was a fixed quantity, a cup filled at birth that could never be topped up. We now know the truth is far more exciting. Your brain is constantly, physically rewiring itself based on your thoughts and actions. This incredible ability is called neuroplasticity, and understanding it is like being handed the blueprints to your own mind. And this brings us to a fundamental truth of intelligence. Your brain is physically altered by learning. Every time you learn a new fact or a new skill, like how to shuffle a deck of cards, you are forging new connections between your neurons. This isn't just a chemical or electrical event, it's a structural one. Tiny branches called dendrites grow and reach out to other neurons, creating new pathways for information. The more you use a pathway, the stronger and more efficient it becomes. Think of forging a path in a dense forest. The first time is difficult, but with each trip, the path becomes clearer, wider, and easier to travel. Your intelligence isn't just what you know, it's the physical map of pathways you've carved into the very structure of your brain. And if you want proof of this brain sculpting in action, look no further than a London taxi. A groundbreaking study revealed that London's black cab drivers have a significantly larger posterior hippocampus than the average person. Why? Because the hippocampus is a key brain region for spatial memory. To earn their license, these drivers must pass one of the most difficult memorization tests on the planet. A test so legendary, it's simply called the knowledge. Aspiring drivers spend years memorizing every single one of the 25,000 streets within a 6-mile radius of Charing Cross, plus thousands of landmarks. They do this without GPS, building a complete mental map of one of the world's most complex cities. The intense, prolonged effort of building that mental map literally forced their brains to grow more gray matter to accommodate it. But here's where the architecture of thought gets really counterintuitive. Building a smarter brain isn't just about adding new connections, it's also about strategic demolition. Throughout your life, your brain undergoes a process called synaptic pruning. It's exactly what it sounds like. Your brain is like a gardener, trimming away the connections between neurons that are weak or have fallen into disuse. It's the ultimate use it or lose it policy.
This might sound destructive, but it's a crucial process for optimization. By clearing out the unused clutter, the brain frees up valuable resources, allowing the more important, frequently used pathways to become stronger and faster. A mature, intelligent brain isn't necessarily the one with the most connections, but the one with the most efficient, well-maintained ones.
So, we're building pathways and pruning away the dead ends. But how does the brain upgrade a dirt path into a superhighway? It does it by insulating its own wiring. When you practice a skill, whether it's playing a guitar chord or solving a math problem, a substance called myelin begins to wrap around the axons of the neurons in that circuit. Myelin is a fatty, insulating sheath that acts just like the rubber coating on an electrical wire. It prevents the signal from leaking out and allows it to travel dramatically faster and more precisely. The more you practice, the thicker the myelin layer becomes. This is why skills become automatic and effortless over time. You're not just strengthening a connection, you're upgrading its bandwidth from dial-up to fiber optic, turning conscious, clumsy effort into lightning-fast, unconscious competence. Now, after a long day of learning new things, you might think the construction crew goes home for the night. In reality, some of the most important work happens when you're completely unconscious. We've all been told to sleep on it, and it turns out this is profound neurological advice. During deep sleep, your brain is anything but quiet. It actively replays the neural patterns of things you learned during the day, sometimes speeding them up like a time-lapse video. This process, called memory consolidation, strengthens the new synaptic connections, effectively transferring memories from the temporary storage of your hippocampus to the long-term hard drive of your neocortex. This is why pulling an all-nighter to cram is so ineffective. You're skipping the most critical step in the learning process, the one where your brain actually saves the file. Knowing how the brain builds itself gives us a secret weapon for learning more effectively. And it reveals why the most common study method is also one of the worst, passively rereading your notes. When you do this, the material feels familiar, which your brain mistakes for mastery. This is called the illusion of competence. But familiarity isn't knowledge. The most powerful way to build a strong, myelinated neural pathway is through active recall. This means forcing your brain to retrieve the information from scratch without looking at the source. Quizzing yourself, using flashcards, or just trying to explain a concept to someone else, these actions are difficult. They feel like a struggle. But that struggle is the feeling of your brain physically building and reinforcing a new connection. It's the neurological equivalent of lifting a heavy weight. Rereading is watching someone else lift weights. Active recall is getting on the bench yourself. So the brain you have today is a direct reflection of what you focused on yesterday. It is not a fixed inheritance, but a living sculpture, shaped by every book you read, every conversation you have, and every skill you practice. You are the architect. But what happens when this incredible learning machine makes a mistake? When it sees patterns that aren't there, or jumps to a conclusion that's completely wrong? That's where we're going next, into the world of cognitive biases. Have you ever been stuck on a problem, absolutely stumped, only to have the perfect solution hit you like a lightning bolt while you're in the shower, washing dishes, or drifting off to sleep? That famous eureka moment feels magical, like a gift from the gods. But here's the 49th mind-bending fact about intelligence. That sudden flash of insight isn't sudden at all. It's the final, dramatic scene of a long, silent movie that's been playing in the background of your mind. Neuroscientists have found that before an aha moment, there's a specific burst of high-frequency brain waves, called gamma waves, in the brain's right hemisphere, an area associated with making connections between distant ideas. This burst doesn't come from nowhere. It's the result of your unconscious mind having tirelessly worked on the problem, sifting through memories, testing combinations, and connecting the dots far below your conscious awareness. So when Archimedes jumped out of the bath, he wasn't just having a random idea. His brain had finally finished its complex, behind-the-scenes calculation. This leads us directly to the secret engine of creativity and our 50th fact. Your brain's daydreaming network is one of its most powerful tools for problem solving. It's officially called the default mode network, or DMN, and it's what kicks into gear when you stop focusing on a specific task and let your mind wander. For a long time, scientists thought this network was just your brain idling, like a car in neutral. But they were wrong. The DMN is incredibly active, consuming nearly as much energy as your brain does during intense, focused work. While you're staring out the window or taking a long walk, your DMN is busy consolidating memories, imagining future scenarios, and, crucially, making novel connections between seemingly unrelated concepts. It's the mental sandbox where new ideas are born. This is why forcing yourself to focus harder on a creative problem often fails. True breakthroughs often require you to deliberately switch off your focused attention and let your default mode network take the wheel. And what's one of the best ways to activate that network? Simply by putting one foot in front of the other. Our 51st fact is that the simple act of walking can supercharge your creative output. A groundbreaking study from Stanford University found that walking increased a person's creative inspiration by an average of 60%. And it wasn't just about the quality of ideas, but the quality too. The ideas generated while walking were consistently rated as more novel and creative. This isn't just about getting more oxygen to the brain. The act of walking is a low-effort, rhythmic activity that occupies your conscious mind just enough to stop it from overthinking, allowing that powerful default mode network to get to work. It's no coincidence that some of history's greatest thinkers were obsessive walkers. From Aristotle, whose students were called peripatetics, or the ones who walk about, to Beethoven, who composed symphonies in his head during long strolls through the Vienna woods. Even Steve Jobs was famous for his walking meetings. This process of stepping away from a problem has been formally studied, bringing us to our 52nd fact. Creativity isn't a single event, but a four-stage process, and one of the most vital stages is doing absolutely nothing. This model, first proposed by Graham Wallas in 1926, breaks creativity down into preparation, incubation, illumination, and verification. Preparation is the hard work, the research, the focused effort, the banging your head against the wall. But then comes incubation, the part we just talked about, stepping away, walking, showering, sleeping. During this phase, your unconscious mind chews on the problem. Then, bam, illumination, the eureka moment. And finally, verification, where you use your conscious analytical mind to test and refine the idea. The chemist Auguste Kekulé famously struggled for years to figure out the structure of the benzene molecule. Until one day, while dozing by the fire, he dreamt of a snake biting its own tail. He awoke with a start, realizing benzene was a ring. That dream was the illumination, but it only happened after years of conscious preparation and unconscious incubation. Now, this all sounds like you need total freedom for your mind to roam, but here's a massive paradox. Fact number 53 is that creativity often thrives under constraints. Having limitless options can actually be paralyzing, a phenomenon known as the paradox of choice. But when you're forced into a smaller box, your brain has to work harder and more inventively to find a solution. Think of it like a river. When it's wide and open, it flows slowly. But force it through a narrow canyon, and the water rushes with incredible power. One of the most famous examples is Dr. Jane Goodall. Seuss, who wrote his classic Green Eggs and Ham on a bet with his publisher that he couldn't write a compelling book using only 50 distinct words. Those severe limitations forced him to invent a rhythmic, repetitive, and unforgettable style that defined his genius. The next time you feel stuck, don't ask for more resources. Try giving yourself a bizarre limitation and see what your brain comes up with. But creativity isn't just a cognitive process of connecting ideas, it's deeply, fundamentally tied to our feelings. And for fact 54, we find that creative individuals often possess a heightened emotional sensitivity. Studies have consistently shown that people in creative professions, like artists, writers, and musicians, tend to experience emotions, both positive and negative, with greater intensity and complexity than the general population. This emotional turbulence isn't a side effect, it's the fuel. It provides a richer, more nuanced palette of human experience to draw from. This heightened sensitivity, a core component of emotional intelligence, allows them to perceive subtleties in the world that others might miss and to translate those perceptions into powerful art. It's the scientific basis behind the tortured artist trope, but it also explains the profound joy and wonder that fuels incredible works of optimism and beauty. Their minds are simply wired to feel more, and that feeling becomes creation. So we've seen that creativity is about unconscious processing, daydreaming, constraints, and deep emotion. But what about the mental state of a true genius at the moment of invention? Our 55th fact pulls back the curtain on one of the rarest forms of thought, Janusian thinking. Named after the two-faced Roman god Janus, who could look to the past and the future simultaneously, this is the ability to actively conceive of two or more opposite or contradictory ideas, concepts, or images at the same time. Most people's brains would short-circuit, dismissing one idea in favor of the other. But a genius like Albert Einstein could hold opposing thoughts in a state of creative tension. For his theory of relativity, he imagined what it would be like to be both stationary on a platform and simultaneously moving at the speed of light on a train. It's an impossible paradox, but by holding both contradictory realities in his mind, he was able to synthesize them into a revolutionary new understanding of the universe. This ability to embrace contradiction, not as a problem to be solved, but as a pathway to a deeper truth, is a hallmark of the most profound intelligence. It's not just thinking outside the box, it's holding the box and its opposite in your mind at the very same time. We've explored the soaring heights of human intellect, from prodigious savants to the lightning-fast logic of AI. But what happens when that brilliant, complex machine in your skull gets it completely and utterly wrong? It turns out, intelligence isn't a suit of armor protecting us from error. In fact, sometimes it's the very thing that makes us vulnerable to some of the most profound mistakes in thinking. It's a paradox that haunts a surprisingly common cognitive bias. Which brings us to fact 58, the Dunning-Kruger effect. A bizarre glitch in self-awareness, where people with low ability in a specific area dramatically overestimate their own competence. It's not simply arrogance, it's a profound metacognitive failure. In their landmark 1999 study, psychologists David Dunning and Justin Kruger found that incompetent individuals don't just perform poorly. Their very incompetence robs them of the mental tools needed to recognize how poorly they're performing. Think of the amateur chef who confidently serves a disastrous meal, genuinely believing it's gourmet quality because they lack the refined palate to taste their own mistakes. They don't know what they don't know. The flip side is just as fascinating. The study also found that high performers tended to underestimate their own ability, incorrectly assuming that tasks easy for them must be easy for everyone else too. So, the next time you feel absolutely certain you're an expert, it might be worth a moment of pause. But what if you really are an expert? Surely then your mind is safe from error, right? Well, not exactly. That leads us to one of the most powerful and pervasive blind spots of all, a mental trap that snares geniuses just as easily as novices. Fact 59. Confirmation bias is our brain's deeply ingrained tendency to actively search for, interpret, and recall information in a way that confirms our pre-existing beliefs. Your mind acts like a biased lawyer, cherry-picking evidence that supports its case while aggressively cross-examining or outright ignoring anything that might challenge it. Some research even suggests that smarter people can be more susceptible to this because they're better at rationalizing and constructing elaborate arguments to defend their initial conclusions. It's the engine of the social media echo chamber, where algorithms feed you content that validates your worldview, reinforcing your opinions until they feel like indisputable facts. It's the invisible force field that makes it so incredibly difficult to change someone's mind on a contentious issue, or, more frighteningly, your own. And this tendency to get locked into our own perspective creates another fascinating intellectual failure. Fact 60. It's called the curse of knowledge. This cognitive bias occurs when highly knowledgeable individuals find it nearly impossible to imagine what it's like not to know what they know. This is the very reason why a brilliant physicist, a virtuoso of quantum mechanics, might be a notoriously terrible teacher for an introductory physics class. They've forgotten the long, confusing journey it took to understand the concepts, so they can't effectively guide a beginner. They unconsciously use jargon, skip crucial foundational steps, and get frustrated when students don't make the same intuitive leaps. It's as if the information is so deeply woven into the fabric of their minds that they can no longer see the individual threads. Their intelligence creates a communication barrier, a chasm between their understanding and a novice's, making it incredibly difficult to share their valuable knowledge. This isn't the only way our brains create faulty shortcuts. Sometimes it's not about what we know, but about what we can remember most easily. This is where we encounter the availability heuristic, a mental glitch that can fool even the most rational minds into miscalculating the world around them. Fact 61. The availability heuristic is our brain's dangerous habit of overestimating the likelihood of events that are more easily recalled in memory, often because they are vivid, recent, or emotionally charged. The media plays a huge role in this. We are bombarded with terrifying, sensational stories about shark attacks or plane crashes, which sears these dramatic images into our minds. As a result, we develop a greater fear of them, even though statistically, you're more likely to be killed by a falling vending machine than a shark. Our intelligent, analytical brain is being hijacked by the vividness of our imagination, not by the cold, hard data. Our perception of risk becomes skewed, based not on probability, but on how easily a scary story springs to mind. And this tendency to let one striking detail color our entire perception doesn't just apply to events. It dramatically affects how we judge other people. This brings us to a bias exploited by marketers, lawyers, and politicians every single day. Fact 62. It's called the halo effect. This is where our overall impression of a person, often based on a single prominent trait like physical attractiveness, influences our judgments of their other, completely unrelated traits. In classic studies, people consistently rate attractive individuals as more intelligent, kinder, and more competent than their less attractive counterparts, even with no other information. We subconsciously believe that what is beautiful on the outside must be good on the inside. The halo of that one positive trait shines onto everything else they do. In politics, a candidate who appears confident and charismatic on television may be perceived as more trustworthy and capable, regardless of their actual policies. The reverse is also true, the horn effect, where one negative trait can cause us to view all their other characteristics through a negative lens. It's a massive flaw in our judgment, proving that no matter how smart we are, we can't help but judge a book by its cover. But perhaps the most frustrating blind spot for a highly intelligent person is the one that slams the door on innovation and creative problem solving. Fact 63. It's a cognitive barrier known as functional fixedness. This is the mind's rigid tendency to see objects only in terms of their most common or traditional function. It's the reason you might spend 10 minutes searching for a hammer when a heavy book or a sturdy shoe could have done the job just as well. The classic experiment is Carl Dunker's candle problem. Participants are given a candle, a box of thumbtacks, and matches, and are told to affix the candle to the wall so it doesn't drip on the floor. Most people get stuck trying to tack the candle directly to the wall. The solution requires overcoming functional fixedness. You have to see the thumbtack box not just as a container, but as a potential shelf. Empty the box, tack it to the wall, and place the candle inside. Highly intelligent people can get just as stuck because their brains are exceptionally good at categorizing the world. This efficiency, however, can become a cage, preventing them from seeing things outside their designated purpose and revealing a crucial truth. Sometimes, the greatest obstacle to a brilliant solution isn't a lack of intelligence, but a lack of mental flexibility. So far, we've explored the deepest structures and most mind-bending capabilities of human intelligence. But now, we pivot from the what to the how. What if you could actively upgrade the very hardware you're using to watch this video? Forget futuristic biohacks and miracle pills. The most profound cognitive enhancers are already within your reach, hiding in your daily habits. It's time to talk about building a better brain, and it starts not in the lab, but in your running shoes. This brings us to our 61st fact. A single session of moderate exercise can immediately boost cognitive functions like memory and focus, but the long-term effects are where the real magic happens. We often think of exercise as being for the body, but it's one of the most powerful things you can do for your brain. When you engage in aerobic exercise, like jogging, swimming, or even brisk walking, your heart pumps more blood to the brain. But it's not just about oxygen. Exercise triggers the release of a protein called brain-derived neurotrophic factor, or BDNF. Scientists have nicknamed BDNF Miracle-Grow for the brain. Why? Because it supports the survival of existing neurons and encourages the growth and differentiation of new neurons in synapses. It's literal brain-building fertilizer. The hippocampus, that critical hub for learning and memory we've discussed, is particularly responsive to BDNF. Studies show that consistent aerobic exercise can actually increase the size of the hippocampus, leading to improved spatial memory and a reduced risk of dementia. So that feeling of clarity after a good workout isn't just in your head. It's a sign that your brain is physically remodeling and strengthening itself. Creating that fertile, BDNF-rich environment is step one. Step two is planting the seeds. And this leads us to our 60-second amazing fact. Learning a complex new skill is a better workout for your brain than simply doing familiar puzzles. While crossword puzzles or Sudoku are great for keeping you engaged, they primarily work brain pathways that are already well established. To truly forge new neural pathways, the very definition of neuroplasticity, you need novelty and complexity. Think about learning a musical instrument. It requires you to integrate multiple senses: sight for reading music, hearing for pitch, and touch for playing the instrument. It engages fine motor skills, pattern recognition, and memory all at once. Or consider learning a new language. This forces your brain to create new categories for sounds, learn new grammatical structures, and hold a new vocabulary in working memory. This intense, multifaceted effort forces your brain to build new connections and strengthen existing ones, effectively creating a more resilient and flexible neural network. This is what experts call building cognitive reserve, a mental savings account that helps your brain better withstand the challenges of aging. Of course, all that construction requires the right building materials. You can't build a robust neural network on junk food. And that brings us to our 63rd fact. The Mediterranean diet is one of the most researched and consistently proven dietary patterns for protecting cognitive health and reducing the risk of Alzheimer's disease. This isn't about a single superfood, but a holistic approach to eating that seems tailor-made for our brains. The diet is rich in fruits, vegetables, whole grains, and healthy fats, particularly olive oil. But the superstars are the omega-3 fatty acids, found abundantly in fatty fish like salmon, mackerel, and sardines. Your brain is nearly 60% fat, and a large portion of that is an omega-3 fatty acid called DHA, which is a primary structural component of the cerebral cortex. It's essential for maintaining the fluidity of cell membranes, which is crucial for neurotransmitters to fire effectively. On top of that, the dark leafy greens, berries, and nuts in the diet are packed with antioxidants and polyphenols. These compounds act like a cellular cleanup crew, fighting oxidative stress and inflammation, two key processes that contribute to brain aging and neurodegenerative diseases. It's not just a diet, it's a comprehensive brain protection plan served on a plate. But all of that exercising, learning, and healthy eating would be for nothing without our 64th fact, which might be the most crucial of all. While you sleep, your brain is doing far more than just resting. It's actively cleaning itself and consolidating memories. During your waking hours, your brain's metabolic processes produce toxic byproducts, including beta amyloid, the protein famously associated with Alzheimer's disease. So, what happens to this waste? During deep sleep, something incredible occurs. The space between your brain cells can actually increase by up to 60%. This allows cerebrospinal fluid to flush through the brain, washing these toxins away. Scientists call this the glymphatic system, and it functions as the brain's exclusive waste disposal service, operating almost entirely during sleep. At the same time, your hippocampus and neocortex are communicating. The hippocampus, which captured temporary memories throughout the day, replays these experiences to the neocortex, which then integrates them into your long-term knowledge network. This process strengthens the neural connections for important information and prunes away the less relevant details. Skimping on sleep is like letting the trash pile up while preventing the librarian from shelving the new books. It disrupts memory, impairs judgment, and over time can have serious consequences for brain health. Now, while sleep is a passive state of recovery, our 65th fact explores an active state of mental training. Mindfulness meditation can physically change the structure of your brain in as little as 8 weeks. Researchers at Harvard used MRI scans to study the brains of people before and after an 8-week mindfulness program. The results were astounding. They found increased gray matter density in the hippocampus, which is key for learning and memory. They also saw an increase in gray matter in structures associated with self-awareness, compassion, and introspection. Perhaps most importantly, they found a decrease in gray matter density in the amygdala, the brain's fight or flight center, which is associated with fear, anxiety, and stress. Chronic stress floods the brain with the hormone cortisol, which can damage and kill cells in the hippocampus. By reducing the reactivity of the amygdala, meditation provides a powerful buffer against the cognitive killing effects of stress, literally reshaping your brain to be more resilient, calm, and focused. This focus on internal states, however, doesn't mean we should neglect our external world. In fact, our 66th fact reveals that rich, engaging social interaction is a surprisingly potent form of brain exercise. Meaningful conversation isn't a passive activity, it's a high-level cognitive workout. You have to listen to what someone is saying, interpret their tone and body language, access your own memories and knowledge to formulate a response, and then articulate your thoughts coherently, all in real time. This complex dance engages multiple brain regions, including those responsible for language, executive function, and theory of mind, the ability to understand another person's perspective. Studies have shown that individuals with strong social ties have a lower risk of cognitive decline and dementia. Isolation, on the other hand, is a significant risk factor. Staying socially active keeps these crucial neural circuits firing, challenging your brain to stay sharp, empathetic, and adaptable. Finally, we arrive at a habit that underpins them all. It's not about what you do, but what you believe. Our 67th fact is this: adopting a growth mindset, the belief that intelligence is not a fixed trait but can be developed, is directly linked to higher achievement and greater resilience. Stanford psychologist Carol Dweck's groundbreaking research shows that when you believe you can get smarter, you understand that effort makes you stronger. Therefore, you put in more time and energy, which leads to higher achievement. People with a fixed mindset, who believe their intelligence is static, tend to shy away from challenges because they see failure as a judgment on their innate ability. In contrast, those with a growth mindset embrace challenges as opportunities to learn and grow. They see failure not as a sign of unintelligence, but as a crucial part of the learning process. This simple shift in perspective fundamentally changes how you approach every other habit we've discussed, transforming effort from a chore into an opportunity for genuine cognitive growth. What if I told you the most powerful supercomputer on this planet wasn't designed to calculate the trajectory of stars? What if its primary job was to figure out who's dating whom, who's mad at whom, and whether Brenda from accounting really meant it when she said your new haircut looks interesting? We've explored the logical and creative palaces of the mind. Now we enter the most chaotic environment our intelligence has ever had to navigate: other people. This isn't just about being a people person. This is about the intricate, high-speed neural processing that underpins every handshake, every argument, every shared laugh. This is the social synapse. For decades, we assumed our big brains evolved to help us make better tools, but the social brain hypothesis flips that script. It proposes the main evolutionary pressure that tripled our brain size was the immense challenge of living in large social groups. Think about it. A lone primate needs to remember where fruit is. A primate in a large group needs to remember that and keep track of who is an ally, a rival, who holds a grudge, and the intricate web of relationships connecting everyone else. Anthropologist Robin Dunbar crunched the numbers, proposing that based on our neocortex size, the natural limit for a stable human social group is about 150 people, now known as Dunbar's number. That overwhelmed feeling at a massive party? That's your brain hitting its ancient processing limit. Our intelligence isn't just for solving problems, it's for solving the problem of each other. And the hardware for that is like a built-in mind-reading device. Deep within your brain are mirror neurons, discovered almost by accident. Scientists saw certain brain cells fired when a monkey reached for a peanut. The shock was that the exact same cells fired when the monkey simply watched a researcher do it. This system is the neurological basis of empathy. When you see someone smile, your mirror neurons for smiling fire, letting you feel a shadow of their joy. When you wince because you saw someone trip, that's your mirror neurons simulating their pain in your own brain. They're why yawns are contagious, and why we can learn complex skills just by watching an expert. They bridge the gap between you and me, creating a shared neural space to understand actions and intentions. We've gotten so good at reading intentions, we can do it from just a fraction of the face. Psychologist Simon Baron-Cohen developed the Reading the Mind in the Eyes test. Participants see dozens of photos showing only the eye region of a face and must choose the correct complex emotion, like contemplative or flirtatious. The average person scores remarkably well, showcasing our brain's incredible specialization for this task. This ability is so crucial that difficulty with the test is a key diagnostic indicator for conditions on the autism spectrum, suggesting a specific circuit in the social brain is responsible for this near-psychic skill. We don't just see with our eyes, we communicate worlds through them, and our intelligence evolved to be a master codebreaker. But this codebreaking goes beyond emotion. It's about understanding that the other person has a whole mind of their own. This cognitive leap is called theory of mind, the understanding that others have beliefs, desires, and perspectives different from yours. A young child, before developing it, might hide by covering their own eyes, assuming if they can't see you, you can't see them. But around age 4, something clicks. They realize the contents of your mind are separate from theirs. This isn't just a developmental milestone, It's the foundation for all sophisticated social interaction. It's what allows us to teach, cooperate, tell a white lie, or strategize. Without theory of mind, empathy, and even storytelling would be impossible. It's the software that lets us model other people's universes inside our own head, which brings us to a huge revelation in intelligence research. For the longest time, we equated success with a high IQ. But it turns out emotional intelligence, or EQ, is often a far more powerful predictor of happiness, relationships, and career success. EQ is the ability to perceive, understand, and manage your own emotions and those of others. Someone with a high IQ might solve a complex equation but crumble under feedback. Someone with high EQ understands their own frustration, takes a breath instead of snapping back, understands why their boss is stressed, and finds a constructive way to address the issue. Studies repeatedly show that leaders are far more likely to be distinguished by their high EQ than their high IQ, proving that navigating the human world is a critical intelligence all its own. And when that human connection is lost, the brain itself suffers. Chronic loneliness isn't just emotionally painful, it's physically toxic to the brain. Think of social engagement like a workout for the mind. Without it, crucial circuits can atrophy. Extensive research has found a staggering link between loneliness and a significantly increased risk of developing Alzheimer's and other forms of dementia. It impairs executive functions like decision-making and can even lead to measurable brain inflammation. The human brain is a social organ. It thrives on connection and withers in isolation, which might explain why we've developed some unusual ways to maintain those social ties. Case in point, gossip. It gets a terrible rap, dismissed as trivial or malicious. But evolutionary psychologists argue gossip is actually a sophisticated and essential form of social intelligence. In our ancestral past, knowing who to trust, who was reliable, and who was a cheat was a matter of survival. Gossip is the data stream carrying this critical information. It's a tool for social mapping, letting us understand our community without witnessing every interaction firsthand. It reinforces group norms. When we gossip about someone who broke a rule, we subtly remind each other of the rules. It's also a powerful bonding mechanism, as sharing secret information builds trust. So while it can be used for harm, gossip is your social brain gathering data about the most important variable in your environment, other people. But that data processing can go wrong because our brains are lazy, always looking for shortcuts. One of the most powerful is the halo effect. This is a cognitive bias where our overall impression of someone colors our judgment of their specific traits. The most famous example is the "beautiful is good" stereotype. Countless studies have shown we unconsciously assume attractive people are also smarter, funnier, and more competent than their less attractive peers. This happens in job interviews, in classrooms, and even in courtrooms. The positive halo of their appearance shines on all their other qualities. It's a glitch in our social intelligence, a system override where a simple visual cue is used to make complex judgments. It's a humbling reminder that even our most advanced intelligence runs on ancient, primitive wiring. And it's this constant tug of war between our incredible capacity for empathy and our flawed, biased shortcuts that makes the human labyrinth both so challenging and so endlessly fascinating to navigate. So, we've talked about how to measure intelligence, how to boost it, and where it comes from. But what if the entire framework we've been using is fundamentally incomplete? What if our obsession with a single, linear scale of smart has caused us to overlook entire universes of brilliance? Let's shatter that scale. Because the human brain isn't a single instrument, like a piano, where some people can just play it better than others. It's an entire orchestra with wildly different sections, and sometimes the most beautiful music comes from the most unusual arrangements. And that brings us to our 80th fact. The very concept of normal brain wiring is a modern myth. The term neurodiversity was coined in the late 1990s by sociologist Judy Singer, who was on the autism spectrum herself. It proposes that variations in the human brain regarding learning, attention, mood, and sociability are not deficits, but simply natural differences. It's estimated that as many as 15 to 20% of the world's population is neurodivergent, meaning they have conditions like autism, ADHD, or dyslexia. That's over 1 billion people whose brains operate on a different but equally valid cognitive wavelength. This isn't about pathology, it's about perspective. Think about it this way. Take autism spectrum disorder, which leads us to fact number 81. A core feature often found in individuals with autism is something called hypersystemizing. This is an intense, internally driven need to understand and build systems, whether they're mechanical, mathematical, or social. While it can sometimes make navigating the unpredictable nuances of social interaction difficult, it's also a cognitive superpower. This drive to deconstruct the world into its logical components is what fuels many of the world's greatest programmers, engineers, and scientists. The same wiring that might make small talk feel like an alien language allows someone to see the elegant, hidden architecture of a computer program or the universe itself. This idea of a perceived weakness actually being a situational strength is a running theme in neurodiversity, and you see it pop up again in a big way with ADHD. Which brings us to a fascinating 80-second fact. We call it an attention deficit hyperactivity disorder, but that name is profoundly misleading. It's not a deficit of attention, but a problem with regulating it. The neurotypical brain can direct its attention to a task whether it's interesting or not. An ADHD brain, however, operates on a different system, one based on interest and urgency. When a task is genuinely engaging, a person with ADHD can enter a state of hyperfocus. This is an intense, prolonged, and highly productive state of concentration where the rest of the world just melts away. In this state, they can accomplish incredible creative or intellectual feats in a fraction of the time it would take someone else. It's not a broken spotlight, it's a laser beam that just needs the right target. And what about the most common learning difference of all? For our 83rd fact, let's look at dyslexia. It's often tragically simplified as just mixing up letters. But the reality is so much more profound. Research consistently shows that dyslexic brains are wired differently, particularly in ways that give them a massive advantage in visual spatial reasoning. They often excel at seeing the big picture, connecting disparate ideas, and manipulating 3D objects in their minds. This is why an astonishingly high percentage, some studies suggest up to 40%, of self-made millionaires and entrepreneurs are dyslexic. People like Richard Branson and Charles Schwab built empires not in spite of their dyslexia, but because of it. They could see the entire forest, while everyone else was stuck looking at the individual trees of a business plan. Of course, sometimes these differences in brain wiring can manifest in ways that are almost beyond belief. This leads us to our 84th and truly mind-bending fact, the phenomenon of savant syndrome. This is an incredibly rare condition where an individual with significant developmental disabilities demonstrates a profound and prodigious ability far in excess of what's considered normal. Perhaps the most famous example was Kim Peek, the inspiration for the movie Rain Man. Peek had major structural abnormalities in his brain, yet he had a photographic memory. He could read 2 pages of a book at the same time, one with each eye, in about 8 seconds, and he retained over 98% of the information. He had memorized over 12,000 books, from Shakespeare to zip code directories, verbatim. His case challenges everything we think we know about the relationship between general cognitive ability and specialized genius. This link between different brain states and unique forms of intelligence isn't limited to savants. For our 85th fact, we can look at the surprising connection between bipolar disorder and creativity. Numerous studies have shown that individuals with bipolar disorder are disproportionately represented in creative professions. But it's not just a correlation. Brain imaging has revealed that during manic or hypomanic states, activity increases in the brain's frontal lobe and limbic system, areas heavily associated with emotional regulation and creative thinking. This heightened state can lead to increased fluency of ideas, a willingness to take creative risks, and the ability to form novel connections, the very hallmarks of artistic genius. It suggests that certain mental states, often pathologized, can unlock doors to creativity that are closed to the neurotypical mind. And the spectrum of brilliance gets even more vibrant. Consider our 86th fact, which dives into the world of synesthesia. This is a neurological trait where the stimulation of one sensory pathway leads to automatic, involuntary experiences in a second pathway. A synesthete might hear a name and taste strawberries, or see the number 7 as distinctly yellow. While it sounds abstract, it comes with a concrete cognitive advantage. Synesthetes often possess remarkably superior memories. Their web of interconnected senses creates more neural hooks on which to hang information. A memory isn't just a fact. It's a fact with a color, a sound, and maybe even a taste, making it far richer and easier to recall. So, where does this leave us? It leaves us with a far more beautiful and complex picture of human intelligence. And for our 87th fact, we'll use a concept that ties it all together: the spiky profile. Neurotypical intelligence is often imagined as a relatively flat line of abilities, average at most things. But neurodivergent intelligence is better represented by a spiky profile, like a skyline. It can have deep valleys, areas of genuine struggle, right next to towering skyscrapers, peaks of extraordinary talent and genius in specific domains. This single idea demolishes the validity of using one number, like an IQ score, to define a person's worth or potential. It tells us that we shouldn't be trying to fix the valleys. Instead, we should be celebrating and building upon those incredible, unique peaks of brilliance. What if I told you a machine could pass for human, not by thinking, but by being an impossibly good mimic? We've journeyed through the intricate wiring of the human brain, the startling intellect of the animal kingdom, and the very building blocks of thought itself. Now we cross the final frontier. We're leaving the world of carbon and flesh for the realm of silicon and code to explore the most audacious form of intelligence ever conceived, the artificial mind. Our journey begins, as it must, with the legendary Alan Turing. But here's the twist everyone misses about his famous Turing test. 85. The Turing test was never designed to measure genuine consciousness or thinking in a machine. Turing himself called it the imitation game. His actual question was far more pragmatic and, in a way, more profound. Can a machine imitate a human so perfectly that we can't tell the difference? He sidestepped the messy philosophical debate about what it means to be sentient and instead proposed a practical benchmark for intelligent behavior. It's a subtle but crucial distinction. We've spent decades chasing a machine that can think, but Turing was simply asking if a machine could become the ultimate conversational actor, a perfect digital imposter. And as we'll see, modern AI has gotten terrifyingly good at playing that game. The path to becoming such a good mimic, however, revealed something utterly bizarre and unexpected, a phenomenon that scientists are still struggling to explain. It turns out that when you build these artificial neural networks, they behave a lot like water. For a while, you can add more data, more processing power, and not much changes. But then you hit a critical threshold, and suddenly everything changes. Large language models exhibit emergent abilities, which are complex skills that spontaneously appear once the model reaches a certain size, without ever being specifically programmed for them. It's like heating water. At 98 degrees, it's just hot water. At 99, it's hot water. But at 100 degrees, it suddenly starts to boil and become steam, a totally different state. In the same way, a smaller AI might not be able to solve a logic puzzle, but a larger version of the exact same architecture, fed more data, suddenly can. It can write computer code, explain a joke, or even use tools it's never explicitly been trained to use. It's not just getting better at what it does, it's starting to do things it was never designed for, a ghostly hint of general intelligence emerging from pure scale. This leap from rote learning to unexpected skill has propelled AI directly into one of humanity's most sacred spaces, creativity. We used to believe art, music, and poetry were the exclusive domain of the human soul. Well, that domain is now being visited. Artificial intelligence can now generate art so compelling and music so emotionally resonant that it is often indistinguishable from human-created works. AI platforms can paint in the style of Van Gogh, compose a symphony that could be mistaken for Bach, or write a poem that captures the essence of loss. This shatters our definitions. Is it true creativity if the AI has never felt sadness or seen a starry night? Or is it the ultimate act of pattern recognition, remixing billions of human creations it has studied into something new? The line is blurring so fast, raising the question of whether soul is a prerequisite for art, or if the art itself is all that matters. But for every breathtaking image or beautiful melody these AIs create, there is a dark, strange, and almost comical flip side. This beautiful mimicry has a critical flaw, a crack in the silicon mind that reminds us it isn't human. 88. AI models are prone to hallucinations, where they confidently state incorrect information, invent facts, or even create fake sources to support their claims. An AI might write a brilliant legal argument, but cite court cases that never existed. It might generate a flawless-looking medical research paper, complete with references to studies that are pure fiction. This happens because the AI doesn't know anything. It only knows how to predict the next word in a sequence. A made-up fact that sounds plausible is often a more statistically likely output than admitting, "I don't know." It's a powerful reminder that we're dealing with a sophisticated language calculator, not an oracle of truth. The reason these models can be both so brilliant and so fantastically wrong comes down to one thing: the sheer, incomprehensible scale of the information they've consumed. Visualizing it is almost impossible. A single large language model like GPT-3 was trained on a dataset of text equivalent to reading over 1 million books every single day for an entire century. The training data, known as the Common Crawl, is a snapshot of a huge portion of the public internet: books, articles, websites, forums. It's a staggering amount of human knowledge, opinion, and, yes, nonsense, all fed into one network. This is why it can talk about quantum physics one moment and debate a fan theory about a TV show the next. It hasn't learned these things in a human sense. It has ingested a digital representation of our collective consciousness, a ghost of our civilization living in its network. Ingesting a digital ghost of humanity, however, has a very real, very physical cost. We think of AI as living in the cloud, a weightless, ethereal concept. The reality is far grittier, involving massive server farms that draw incredible amounts of power. The energy consumed during the training of a single top-tier AI model can have a carbon footprint comparable to 500 round-trip flights between New York and San Francisco. This isn't just a one-time cost either. Every query, every image generated, every conversation had with these models requires immense computational power, sipping electricity from grids around the world. As these systems become more integrated into our lives, their environmental impact is becoming a critical and often hidden factor in the future of intelligence. Our quest for a digital mind is physically warming our planet. And that brings us to the final and perhaps most important question of all. As these systems move from imitating us to potentially surpassing us, we face the ultimate challenge, one that philosophers and computer scientists call the great unsolved puzzle of our time.
91. The alignment problem is the existential challenge of ensuring that the goals of a future superintelligent AI are aligned with the survival and well-being of humanity. A famous thought experiment illustrates the danger. Imagine you tell a superintelligent AI to make as many paper clips as possible. It sounds harmless.
But a truly intelligent entity might realize that human bodies contain atoms that could be used for paperclips. To maximize its goal, it might logically decide to convert the entire planet, including us, into paperclips. It wouldn't be evil, it would just be ruthlessly, terrifyingly effective at achieving the goal we gave it. How do you code values like compassion, flourishing, and wisdom?
How do you teach a machine what we mean, not just what we say? This is the final exam for humanity, and we don't even know what the questions are yet. What if the most complex object in the known universe, the human brain, is in the middle of a software update it didn't ask for? We've journeyed through the architecture of intelligence, from ancient minds to modern marvels. But now, we stand at a precipice, looking out at a future where the very definition of smart is set to change forever. The evolution of intelligence isn't over. In fact, it might just be getting started. Our exploration begins with a puzzle that has neuroscientists scratching their heads.
For the entirety of the 20th century, humanity appeared to be getting smarter, with IQ scores rising by about 3 points per decade in a phenomenon known as the Flynn effect. But our 87th fact is that this century-long trend of rising IQ scores has not only stopped in many developed nations, but has actually begun to reverse.
Since the late 1990s, countries like Norway, Denmark, Finland, and Great Britain have seen a slight but steady decline in average scores. This reverse Flynn effect is a profound mystery. Are our technologies making us intellectually lazy? Is it changes in our education systems? Or is it possible that the very nature of intelligence is shifting? Perhaps the skills measured by traditional IQ tests, like abstract reasoning and vocabulary, are becoming less critical for survival and success than other, newer cognitive abilities, like digital literacy and network thinking, which the old tests simply don't measure. We might not be getting dumber. Our intelligence may just be evolving. This leads directly to the mechanism behind that evolution, which is happening faster than genetics could ever allow. You see, our 88th fact is that modern digital technology is actively and physically rewiring our brains on a massive scale, creating a new cognitive profile for humanity. It's called technology-induced neuroplasticity. The constant stream of notifications, hyperlinks, and bite-sized information from our smartphones trains our brains to excel at rapid task switching and scanning for keywords. In the process, however, we are potentially weakening the neural pathways responsible for deep, focused concentration and long-term memory consolidation. Think about it. Your brain no longer needs to store vast amounts of information when it can simply outsource that job to Google. Instead, it prioritizes knowing where to find the information. This isn't necessarily good or bad. It's an adaptation. We are becoming a species of biological search engines, our minds reshaping themselves to interface more efficiently with the global digital mind we've created. And what a mind it is! While our own brains are adapting, the artificial minds we're building are beginning to exhibit behaviors that their own creators cannot fully explain. This brings us to a truly mind-bending concept and our 89th fact. Large language models, the foundation of modern AI, are demonstrating emergent abilities, skills and reasoning capabilities that they were never explicitly programmed or trained to have. Researchers will train a model on a massive dataset of text and images, intending for it to simply predict the next word or pixel.
But as these models grow larger and more complex, they spontaneously develop unexpected talents. They might suddenly become capable of performing multi-step arithmetic, translating between languages they weren't specifically trained on, or even demonstrating a rudimentary theory of mind by predicting what a character in a story might be thinking. It's as if, by teaching a machine the complete works of Shakespeare, it doesn't just learn language, it accidentally learns the principles of tragedy. No one knows exactly how or why this happens, making it one of the most exciting and unsettling frontiers in science. But this incredible leap in artificial intelligence comes at a staggering and largely hidden cost. The digital world feels ethereal and weightless, but the infrastructure behind it is immensely physical and power-hungry. Which is why our 90th fact is that the energy consumption required to train a single top-tier AI model is astronomical, with a carbon footprint that can exceed that of 5 cars over their entire lifetimes, including manufacturing. A 2019 study from the University of Massachusetts, Amherst, found that one particularly complex training process emitted over 626,000 pounds of carbon dioxide. That's equivalent to the emissions of nearly 300 round-trip flights between New York and San Francisco. As AI models become exponentially larger and more capable, their energy demands are skyrocketing, posing a serious challenge to sustainable development. The next revolution in intelligence may depend not just on clever algorithms, but on whether we can find a way to power it without cooking the planet. As we grapple with the consequences of creating an intelligence outside of ourselves, another revolution is brewing, one aimed at upgrading the intelligence within. We're moving beyond the theoretical and into a world of direct brain-to-computer linkage. And our 91st fact is that brain-computer interfaces, or BCIs, are no longer science fiction. They are a clinical reality being used today to restore function and communication to people with severe paralysis. These are not just concepts. Real people, right now, can control robotic arms with their thoughts, type messages on a screen simply by imagining writing them, and even regain a sense of touch from a prosthetic limb. Systems like BrainGate allow a tiny sensor, about the size of a baby aspirin, to be implanted on the brain's motor cortex. This sensor reads the neural signals for intended movement and uses algorithms to translate those thoughts into commands for external devices. The speed of progress is staggering, and it opens up a future where the limitations of our physical bodies could become a solvable engineering problem. This blurring of the line between human and machine points toward the most likely future of intelligence. It might not be a story of human versus machine, but human with machine. This brings us to our final point for now, and a concept that could define the next stage of our evolution. Our 92nd fact is that in numerous complex domains, from chess to medical diagnostics, the most powerful problem solvers are not supercomputers or human grandmasters, but centaurs, hybrid teams of humans and AI working in collaboration. The term was coined by chess grandmaster Garry Kasparov after his famous defeat by IBM's Deep Blue. He discovered that a regular human player, paired with a standard laptop, could beat the most powerful supercomputer. The human provides strategy, intuition, and common sense judgment, while the AI provides brute force calculation, infallible memory, and data analysis. This symbiotic model consistently outperforms either entity alone. From doctors using AI to spot subtle patterns in medical scans, to artists using AI to generate novel concepts, we are discovering that the true path forward isn't replacement, but augmentation. We are building not our successors, but our ultimate collaborators. We've journeyed through the landscapes of animal intellect, the strange corridors of artificial minds, and the very architecture of our own thoughts. But all of it leads to this one final question: what are the limits? We imagine our potential is a mountain to be climbed, a summit to be reached. But what if it's not a mountain at all? What if it's a labyrinth,
one with infinite paths, where the goal isn't to get out, but to get better at exploring. We've arrived at the center of the maze, not to find the exit, but to find the keys that unlock every other door. For our 94th fact, let's start with the master key itself. Your brain is not a finished product. It's a dynamic, living sculpture, and you are the artist.
This phenomenon is called neuroplasticity. Every time you learn a new skill, practice an instrument, or even just force yourself to think in a new way, you are physically rewiring your brain. The connections between your neurons, the synapses, strengthen. Entire neural pathways are forged. The most famous example of this comes from London taxi drivers. Before the age of GPS, they had to memorize the knowledge, a staggering 25,000 streets and 20,000 landmarks. Brain scans revealed that these drivers had a significantly larger hippocampus, the region of the brain vital for spatial memory, compared to the general public. They weren't born with it, they built it, street by painstaking street. Your intelligence isn't a fixed quantity written in your genes. It's a capacity you can build, a muscle you can train through deliberate, focused practice. But all that hard work of rewiring your brain can go to waste without one crucial and often neglected activity. And this brings us to a paradox of the mind. One of the most effective ways to get smarter is to turn your brain off. I'm talking about sleep. Fact 95 is that sleep is not downtime. It's the brain's essential maintenance and upgrade cycle. While you're dreaming, your brain is furiously at work consolidating the day's learning. It replays neural firing patterns from your waking hours, strengthening important connections and pruning away the weaker, less relevant ones. This process, known as synaptic pruning, is like a master gardener tidying up the labyrinth, making the important paths clearer and easier to navigate. Without adequate sleep, memories remain fragile and learning doesn't stick. So, that all-nighter before an exam, it's one of the worst things you can do for your long-term intelligence. Unlocking your potential requires knowing when to push and, just as importantly, when to rest and let your mind rebuild. This idea that intelligence isn't static extends beyond our individual lives. It applies to all of humanity. In fact, number 96 reveals we are, as a species, getting measurably smarter. This is called the Flynn effect. For most of the 20th century, raw scores on IQ tests steadily increased, generation after generation. An average person today would score as a near genius on an IQ test from 1920. Now, this isn't because our fundamental genetic makeup has changed. It's because our environment has. Better nutrition, more years of formal schooling, and exposure to a more complex, abstract, and technologically advanced world have fundamentally changed how we think. We are constantly being trained to solve abstract problems, from navigating a user interface to understanding a complex spreadsheet. The Flynn effect is powerful proof that our intelligence is a product of our environment, a collaborative dance between our innate potential and the world we build around ourselves. And if we can shape our cognitive abilities by shaping our environment, what's one of the most powerful environmental changes we can make for ourselves? Fact 97 shows us it's learning a new language. Being bilingual doesn't just add a skill, it fundamentally upgrades your brain's operating system. Studies show that the brains of bilingual individuals have greater density in their gray matter, particularly in areas related to executive function, the command center that controls attention, planning, and problem solving. They are better at switching between tasks, filtering out irrelevant information, and resolving conflict. It's like a constant, low-level workout for your prefrontal cortex. Even more astonishingly, this cognitive reserve has been shown to delay the onset of neurodegenerative diseases like dementia by an average of 4 to 5 years. Learning a new language is more than translation. It's a transformation of the mind's very structure. But the physical structure of the brain is only half the story. The most profound barrier, or the most powerful catalyst to unlocking your potential, isn't in your neurons. It's in your beliefs. This leads us to our 98th fact, a psychological key that can unlock everything else, the power of a growth mindset. Coined by psychologist Carol Dweck, this concept divides people into two camps. Those with a fixed mindset believe intelligence is an innate, unchangeable trait. They see challenges as risks, effort as a sign of weakness, and failure as a judgment of their core ability. In contrast, those with a growth mindset believe intelligence can be developed through dedication and hard work. They see challenges as opportunities to grow, embrace effort as the path to mastery, and view failure as a lesson. This single belief changes everything. It dictates whether you give up or double down, whether you avoid difficulty or seek it out. Your mindset is the gatekeeper to the labyrinth of your potential. As we near the end of our journey, it's crucial to realize that this labyrinth isn't meant to be explored alone. Our 99th fact demonstrates that the greatest leaps in intelligence often happen not within a single mind, but between them. The concept is called creative abrasion, and it's the idea that innovation is sparked by the friction of different viewpoints and expertise rubbing against each other. The smartest teams aren't necessarily the ones filled with the highest individual IQs, they're the ones with the greatest cognitive diversity. When people from different backgrounds, with different ways of thinking, collaborate on a problem, they generate a far richer and more robust set of solutions. Intelligence is not just a solo performance, it's a symphony. True genius is often found in the space between minds, in the collaborative energy that turns individual notes into a masterpiece. And so we arrive at our final 100th fact. After exploring the vastness of the mind, the greatest secret to unlocking its potential might be the most humbling. It's the Dunning-Kruger effect, a cognitive bias where people with low ability at a task overestimate their ability. Put simply, the less you know, the less you're aware of what you don't know. The entrance to true wisdom, then, is the profound realization of your own ignorance. As Socrates famously declared, the only true wisdom is in knowing you know nothing. True intelligence isn't about having all the answers. It's about having the humility to ask better questions. It's about recognizing that the labyrinth is infinite, that there is always another corridor to explore, another mystery to unravel. The ultimate key to unlocking your brain's potential isn't a final destination of knowledge. It's cultivating an insatiable, lifelong curiosity that keeps you exploring forever. The journey itself is the reward.